This video is dedicated for molecular orbital theory examples. So, pagko-construct lang tayo ng examples ng molecular orbitals. So, last time, nag-construct ako ng molecular orbital ng oxygen. So, oxygen is what you call a homonuclear diatomic. So, sa Chem 18 and Chem 40 or sa mga service courses, we'll only be dealing with diatomic molecules. So, ibig sabihin, dalawa lang yung atoms na involved. So, homonuclear means they have the same orbitals or they have the same nucleus. Parehong oxygen yung involved sa O2. Okay? So, basically, the energies of those orbitals are the same. Kaya, yung molecular orbital natin ay pareho lang yung energy dun sa oxygen 1 and oxygen 2. So, this cyanide molecule is an example of a heteronuclear diatomic. Heteronuclear because carbon and nitrogen are not the same atom. Okay? Cn minus. So, that's how you classify yung mga diatomic molecules. Okay? So, paano naman tayo magsusulat ngayon ng molecular orbital ng isang heteronuclear diatomic? Okay? So, ngayon, nakita nyo na dyan sa screen yung number of electrons ng C at saka ng N. So, we'll add another electron for the negative charge. Okay? So, that negative charge is in addition to the 6 electrons of carbon and 7 electrons of nitrogen. So, tingnan muna natin kung paano mag-interact yung mga orbitals. So, for 1s, meron tayong sigma bond between 1s molecule. We'll designate it as sigma 1s. Okay? While the overlap of 1s orbitals of different phases is the sigma star 1s. Okay? So, yan yung interaction ng mga 1s ng carbon and nitrogen dun sa cyanide molecule. So, next is the 2s. So, they're slightly bigger, pero the interaction is the same because they are still s orbitals. So, this will be called sigma 2s. And the out of phase overlap or different phase overlap is called sigma star 2s. Okay? So, let's go to the 2p orbitals. Okay? So, yung 2px, 2py, and 2pz. So, yung 2px, sila usually yung nag-exhibit ng sigma bond because they are the horizontally oriented, okay, orbitals. So, you can actually set this differently depende dun sa coordinates nyo. So, ang aking base coordinates, this is the z-axis, the y, and the x. So, pwede kayong mag-set ng ibang way kung paano nyo ipoproject yung axis. Basta dapat consistent kayo all throughout. Okay? So, this will be sigma 2px. Okay? While the out of phase overlap is the sigma star 2px. Okay? How about 2py? So, 2py is an interaction that is side to side. Okay? So, kapag same phase yung nag-overlap side to side, that would be a pi bond. Okay? So, pi bond siya kasi merong meron tayong nodal plane dun sa internuclear line. So, that's a pi bond. Pi 2py. And yung overlap na opposite ang phase, that would be pi star 2py. Okay? So, yun yung overlap nila. Ganyan. 2pz. So, ang 2pz natin, yung nakatayo. Okay? Same phase, side by side, overlap. That would be 2pz. While the out of phase overlap, okay, is a pi star 2pz. So, na-exhibit na natin lahat ng interactions. We'll now write the molecular orbital. So, this side is for carbon, this side is for nitrogen. So, unahin natin yung 1s. So, this is an arbitrary representation of the energy of the 1s of carbon. So, with respect to carbon, yung nitrogen kasi ay mas electronegative. So, mas negative yung energy nung 1s ng nitrogen kaysa kay carbon. So, we should put this at a lower level kaysa dun sa carbon. Okay? So, ganyan. Ngayon, yung resulting orbitals niya, yung sigma 1s, dapat mas mababa siya dun sa 1s ni nitrogen, and mas mataas naman yung sigma star kaysa sa 1s ni carbon. Okay? O, ganyan. That would be the interaction between the 1s. Okay? How about the 2s? So, ganun pa din. Mas mataas ang 2s ni carbon kaysa kay nitrogen. So, ganyan. Okay? How about 2p? So, delete muna natin tong area na to para may space. Okay? Tingnan natin muna initially kung ilan ang electrons ni cyanide. So, meron tayong 14 electrons. So, meron tayong rule. Ayusin ko lang. 14 electrons. So, meron tayong parang phenomenon kapag meron tayong 14 electrons and below dun sa molecular orbital. So, that would be called the sp mixing. So, sp mixing is a kind of a hybridization or mixing of the s and the p orbitals of carbon and nitrogen, or the carbon-nitrogen molecular orbital before or prior to the creation of the molecular orbital. Okay? So, this is a complicated concept na we can discuss sa higher chemistry, pero dito hindi muna natin kailangan ng ganun ka lalim na concept. So, what we only need to consider kapag meron tayong sp mixing is that if the number of or the total number of electrons in the system is 14 and below, ang mangyayari yung pi, okay, the pi will have a less energy than the sigma dun sa 2p orbital. Okay? So, ganyan. Yung mga pi interactions ay mas mababa sa mga sigma interactions. So, normally, dun sa oxygen, last time, makikita nyo dun sa oxygen last time na yung sigma 2p ng oxygen ay mas mababa kaysa dun sa pi 2p interactions ng oxygen. Pero in this case, since this only has 14 electrons, okay, so oxygen has 16 electrons, so that's greater than 14, so walang sp mixing. Okay, so ngayon, the sp mixing does not happen sa antibonding. So, the sigma interaction is still at a higher energy than the pi. Okay, ganyan siya. So, ganyan ang nangyayari sa sp mixing. Okay? So, yan na yung molecular orbital ng cyanide. Itan natin para makita natin lahat. Okay? So, yan na siya. So, since 14 number of electrons, so, lagyan natin ng 14 electrons yung molecular orbital. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay? So, yun yung number of electrons dun sa Cn- molecule. So, we can see that the HOMO, okay, HOMO is sigma 2p. Okay? It can be 2px or 2py. Basta kapag 2p at sigma band, automatic na alam na natin kung ano yung 2p orbital na yon. It may be 2px, okay, or it may be another axis kasi hindi naman tayo pare-pareho ng designation na axis. So as far as my axis is concerned, this is the 2px, the sigma formed from the 2px orbitals. Okay? The LUMO is the one next to the HOMO. Okay? That's directly above the HOMO. So the LUMO is pi star 2p. So the pi star 2p consists of both the pi star 2py and the pi star 2pz. So collectively, tinatawag lang natin silang pi star 2p. So alam naman din natin kung anong mga 2p orbitals ang nag-exhibit ng pi band. So no need to to expound on this. Okay? O yan. Yan yung molecular orbital ng CN. So the bond order. So last time, correct ko lang last time, it's not orbitals, it's the number of electrons that you count. So 1/2 times the number of bonding electrons, okay, minus the number of anti-bonding electrons. Okay, so that's bond order. So bilangin natin. So number of bonding electrons is 2, 4, 6, 8, 10. So that's 10. 1/2 times 10 minus anti-bonding is 2, 4, 4. Okay. So this will be 6/2, 3. So ang cyanide, okay, drawing natin yung molecular orbit or yung Lewis structure ng cyanide. C, triple bond, N. Okay? So, yung negative charge ay nasa bandang C. Ganyan ang ating cyanide molecule. Okay? Triple bond siya. So, pansin nyo, hindi nagfa-follow ng octet role si carbon because it has an additional electron dun sa kanyang atom. Kasi, actually, hindi naman additional electron. This is just the formal charge of carbon in that structure. Okay? So, kung i-calculate nyo kasi yung formal charge nito, that's Fc of carbon. Okay? That would be 4 minus 3 minus 2. That would be negative 1. Okay? Yung nitrogen naman, okay, calculate natin. Ang number of valence ng nitrogen ay 5 minus 3 minus 2, 0. So, sa Lewis structure, yung carbon yung nagpo-possess ng negative charge. Okay? So, I hope this helps dun sa pag-understand nyo ng molecular orbital theory and how to construct molecular orbitals of simple diatomic molecules.